What did we say average rate of change really was? It's a slope, which is y2 minus y1 over x2 minus x1. By the way, the videos online are current, so. That says find the average rate of change from 0 to 2. That means x equals 0 to x equal 2. But in order to find the average rate of change, I may have the x values. What do I need? The y. And my function is f of x equals minus x cubed plus 1. If x equals 0, then I'd have that y equals 1. And if x equals 2, well, that would be minus 2 cubed plus 1, which would be minus 8 plus 1 looks like, what, minus 7? So that this says I have a coordinate point. I'm going from 0, 1 to x equal 2, y equal negative 7. And now it's just the slope of the line. So I'm going to, instead of calling it the slope, I'm going to call it average rate of change. And we use this in brief calculus, AROC, average rate of change, is going to be the change in y minus 7 minus 1 over the change in x, 2 minus 0, which is minus 8 over 2, or minus 4. Now, what does that mean? What does that mean? What's it telling me? It's telling me about the relationship between x and y. Right? And what's it telling me about that relationship? For every 1 unit on the x, what happens to y? It's going to be going down 4 units. So it's telling me essentially as x changes, y decreases, right? Or, and specifically, if this were a cost function, for every unit, and it could be every 1,000 units, but for every 1 unit, whatever the units are, I produce, the cost goes down 4 units. Or for every book I purchase, my bank account goes down 4 units. Right? That's probably more real to you. Find the average rate of change from 1 to 3. So that says I have x equal 1, x equal 3. So now I put in x equal 1 minus 1, so 1 cubed is 1, minus 1 plus 1 is 0, so this is y equals 0. And 3 is a little bit more work. 3 is going to give me minus 3 cubed plus 1, which is minus 27 plus 1. Minus 27 plus 1 is minus 26. So my 2 coordinate points are x equal 1, y equals 0, and x equal 3, y equal negative 26. Now, by the way, this is a curved object. Minus x cubed plus 1 is a curved object. So that means the slopes are not going to be the same. So what's the average rate of change? AROC is minus 26 minus 1. Oh, isn't this cute? Divided by 3. We've got a number divisible by 3. That is adorable. Minus 27 divided by 3. Minus 27 divided by 3 is negative 9. What did I do? Yeah, changing, oh.
It's going to be negative 9, so yeah.
Oh, cramola.
3 minus 1.
Since I'm video, I have to watch my language and fix this. So, minus 26 minus 0, 3 minus 1 is now going to be minus 26 divided by 2, which is minus 13. Oh, thank you. Which means what? So I go over 1, because that's what that denominator is, and then I'm going to go down 13. You do the next one. Tell me what you come up with. What you come up with? One. Negative 1. Where'd you get the 1?
1 minus negative 1.
Let's see. 2. Oh. 2 minus 0, 1 minus a negative 1, so I was right. Well, that can't be true. Oh, it is 1 minus a negative 1. Yeah. Which comes out to be a positive 2, which comes out to be a positive 1. I checked that twice. Oh. But that's a positive slope. That says I'm going to go over 1, I'm going to go up 1 from that thing.
It's just the top 102.
Oops. Where's the graph? So 1, 0 is here. And negative 1, 1 is there. And see, no matter what 2 points I pick, this thing's always decreasing, so I can't be a 1.
Zoom in on white.
It can't be a 1.
It's 0 minus 2.
It's
not
0 minus 2.
Not 2 minus 0.
Over 1 plus 1. Negative 2 over 2. Negative 1. Yeah, negative 1.
Well, I was right to begin with.
You're only-
Because, no, I'm not. 2 minus 0, and then minus 1, minus 1. That gave me a negative 2, which then gave me a, we're back to where we are, which was a negative 1. So I just did 2 minus 0, negative 1 minus 1. That way, you could do it the other way as well. You come up with negative 1, so that means that's not the correct. You're going to go over 1, and then you're going to go down 1.
But isn't it x2 minus x1?
Well, it doesn't matter.
But that changes, it changes from 1 to...
No, it doesn't, because if I go 0 minus 2 divided by 1 minus a minus 1, this gives me negative 2 over positive 1, which is still negative 2, or negative, positive 2, which still gives me negative 1.
But isn't that... You're taking... That's x1 minus x2.
But it doesn't matter, as long as they're in the same order.
But they're in a different order there, that's what I'm saying.
But what I'm saying is this. 2 coordinate points are 2 coordinate points. My 2 coordinate points are negative 1, 1, and negative 1, 2. And I hate when I write it that way. 1, 0. So negative 1, 2, and 1, 0. If I write it this way...
Wait, sorry, isn't it 1, 2? It should be 1 comma 2. Because 1 cubed plus 1 is 2.
It's negative x cubed.
If I look at y being equal to negative x cubed plus 1, if x equals negative 1, y equals minus a minus 1 cubed plus 1. No. Which is minus 1 plus 1, which actually, this is a minus 1 plus 1, which is 2. So it's negative 1, 2. And if x equals 1, then I get that y equals minus 1 cubed plus 1, which is 0. So it's 1, 0, and negative 1, 2. Now, the point I wanted to make is this. Is this not the same set of coordinate points? So it doesn't matter whether I take 2 minus 0 over, and I started here, minus 1 minus 1. This is going to reverse it, or 0 minus 2 over 1 minus a minus 1. You're going to end up in the same place. Doesn't matter who's first and who's second. Is that y1 minus, or y2 minus y1 over x2 minus x1. If I factor a negative 1 from the numerator, and I factor a negative 1 from the denominator, what's minus 1 divided by minus 1? 1. These are the same two formulas. That's why what I normally point out is that the coordinate points should be together. So this should be x, y, the same coordinate point. This should be x, y, the same coordinate point. Doesn't matter which one comes first. So he has a slope of negative 1. Pick points on a graph and draw a line through them that is the secant line. Secant line is just a line that goes through 2 points on a graph. And the slope will change, as we saw, depending upon what 2 points you pick. I picked 2 different points. This guy will have, that secant line will have a completely different slope. But it's dependent upon the 2 points that you pick. The slope will change. And then it says, find the average rate of change from -1 to 2. Find an equation of the secant line containing the points -1, g of -1, 2, g of -2. The reason why they wrote it this way is they didn't give us the y values. It's just the y values we're going to calculate out. So in order to find the average rate of change, and that's going to be part A, if I know that g of x is equal to x squared plus 1, then I need the coordinate point when x is -1. So g of -1 equals -1 squared plus 1, which is 2. So one of my coordinate points is going to be -1, 2. I need a second coordinate point, and that says from -1 to 2, I need g of 2, which is 2 squared plus 1, which is 4 plus 1, or 5. So my second coordinate point is going to be x equal 2, y equal 5. If I'm going to find an equation of the line, so equation of the line, I need 1, the slope, and 2, a point. I have 2 points. What don't I have? I don't have the slope, right? So here we go. The first thing I'm going to do is find the average rate of change, which is the slope. AROC equals 5 minus 2 over 2 minus a minus 1, which is, oh, is that not so cute? It just hurts. Which is 3 over 3, or 1. So the average rate of change is 1. That means for every 1 unit I go to the right, the graph goes up 1 unit. So it's 1 to 1. And now they want me to find the equation of the line. So I have the AROC, which is 1. That happens to be the slope. So part B, I need the slope, which is 1. I need a point. Doesn't matter which point I choose. Now I'm going to choose 2, 5. Why would I choose 2, 5 over -1, 2? I don't have to deal with negatives, yeah. Because what are the chances I'll make a mistake if I use a negative? Pretty good. However, I usually don't give you a choice. If I'm going to have you do anything, both coordinate points will have 1 negative in it, so you don't have, aren't I evil? No, I take that back. I'm not evil. And then I personally use this, y minus y1 equals m times x minus x1. And so this says y minus 5 is equal to m, which is 1, times x minus 2. That's a perfectly good answer. Unless they tell you to write it in a specific form, leave it. I would quit while I am ahead. This one's easy enough to put into slope-intercept form because there's a 1 there.